Hi guys, welcome back to my channel. Today we are talking about something super practical. I will show you how to easily align the suspension of your RC car. I have a really simple, affordable method that I use on all my RCs, and honestly, it works great. If you want to save a bit of cash, this is the way to go. For today's demo, I will be using my 1/16 scale Traxxas E-Revo. On this one, both camber and toe are adjustable on the front and rear axles. But don't worry, this trick works for pretty much any RC car with adjustable suspension. So check this out. If you look at the inner thread on my tires, it's completely worn down. That's a clear sign that the suspension is off and I need to do a proper alignment. Now, I bought this car used, so I've got no idea if the previous owner messed around with the settings. But what I did was to change the ride height. I set it pretty low since I usually drive on asphalt, and that alone already affects the camber. Let me show you what happens when the suspension compresses. See that? The camber angle goes a few degrees more negative. It's designed like that so that the outside wheels get better grip when the car leans into a corner. The thing is, lowering the ride height basically does the same thing. It increases negative camber. That can be great for cornering, but it also makes the car less stable overall. The tires don't sit flat on the surface, and that's why the inner part of the tread wears down so fast. Let's start by checking the initial setup. It's super important that the car is in its ready to drive condition. That means the battery has to be installed too, because the extra weight actually lowers the chassis a little bit. Now, this tool here is a camber gauge. You can pick up one pretty cheap at most hobby shops. It makes measuring the camber on each wheel really easy. Okay, let's take a look. On the rear axle, I'm getting about 4 degrees of negative camber. Let's move up front. Here we've got roughly 2.5 degrees of negative camber. According to the Traxxas manual, the recommended starting point is around -2 degrees on both the front and rear axles. So with my 4 degrees in the rear, I'm way off the target. The 2.5 degrees in the front isn't too bad though, but personally I think -2 is still a bit too much. So I'm going to start with -1 degree on both the front and the rear. That should make the car a little less aggressive in corners, help reduce those annoying traction rolls and improve straight line stability at the same time. I had these plexiglass plates made to make adjusting the camber and toe angles a lot easier. I actually got the idea from another YouTuber's channel and thought it was brilliant. The plates are simply bolt on instead of the wheels, and that lets you quickly measure and tweak the suspension settings. The E-Revo uses what's called a pillow ball or pivot ball suspension. Basically, there's a ball threaded into the end of each suspension arm, and that ball sits inside the hub, which then holds the axle. All the plates are mounted now. I designed these 2 large holes so that I can still reach the adjustment screws for the pillow balls. Turning the upper screw in makes the camber more negative, while turning it out makes it more positive. The lower screw works the other way around. My goal is to make the camber just a bit less negative, so I need to tilt the top of the wheel slightly outward, away from the body. I do that by turning the upper screw out a half turn and the lower screw in half a turn each time. I've also installed adjustable tie rods on my E-Revo, which makes the alignment way easier. That's because camber and toe always affect each other when you are making adjustments. After fine-tuning both screws, I checked the camber again. My gauge is set to -1 degree and everything looks good. Both sides of the rear axle are now dialed in perfectly. I adjusted the front axle the same way. My camber gauge reads -1 degree here as well. Maybe a bit more, around 1.5, but I'm happy with that for now. Next one is toe adjustment. Like I mentioned earlier, I came up with a super simple and cheap method for this. If you take your time and work carefully, the results are surprisingly good. I used this on all my RCs and honestly, they drive perfectly straight on the first test run without any extra tweaking. Here's what I do. I take a large sheet of paper and draw a few reference lines. The center line is important for lining up the car, and the outer lines help to position the chassis and the adjustment plates. Right now, I've marked 0 degrees. My target values are -2 degrees in the rear, which is called toe in, and 0 degrees in the front, which means that the wheels run in parallel. Then I place the car on the paper, making sure it's lined up perfectly with the center line. You can already get a rough idea of how the toe is set. For the rear I want 2 degrees of toe in, but right now it looks pretty much at 0. I will start with the rear axle. On the right side we need more toe in. I can get it by lengthening the tie rod. Just make sure you turn it in the correct direction. And as always, take small steps, like a quarter or half turn at a time, then measure again. This is how it should look when the toe is adjusted. Beside the 0 degree line, I have added another reference line at -2 degrees. After a proper adjustment, the plexiglass plate should be perfectly aligned with this line to ensure the toe in is correct. Next, I do the same thing for the front. I recommend briefly turning on the car so that the servo centers itself. And don't forget, make sure the steering trim on your transmitter is set exactly to 0. That's important so that the car runs straight when everything is adjusted. Now for measuring. On the front axle, I'm aiming for 0 toe, meaning both front wheels should be perfectly parallel. There's always a little play in the steering, which is pretty much unavoidable, so you just have to eyeball it and find a good setting. Finally, just to be clear, it isn't the most precise method there, but for me it works great. My cars always drive perfectly straight afterward, and considering there's a bit of play in the suspension anyway, you can't fully rely on perfect numbers. Still, it's a super cost-effective way to get your setup dialed in. Have fun trying it out.